In this video, we're gonna talk about the equation of the plane in three-dimensional. So you see the picture here that you have the thing that called plane. And in order to find the equation of the plane will be the thing that you need to know is going to be how could we determine a plane when we know one point. So if you have a plane, okay, the thing that gonna use to distinguish between two plane turned out to be, you see that if you use the vector that lies on the plane, okay, so if you use the vector that lies on the plane, it's not gonna be unique because you can have more than one vector. Okay, so you can have more than one vector that lies on your plane. So it's not possible to use the vector that lies on your plane. The thing that mathematician will use turn out to be is gonna use the vector that gonna perpendicular to this plane. So if you have the plane, the thing that always turn out to be the direction turn out to be the vector that perpendicular to the plane that can be used to determine the plane. So in order to find an equation of the plane, the thing that we're going to use is going to be the vector that perpendicular to that plane, and that guys is called normal vector. So this one is called normal vector. So the normal vector will be the vector that perpendicular or orthogonal to the plane. Okay, so that's what I wrote here. Okay, so you have first to determine the normal vector. The second one that you're gonna need is gonna be, you need one point on the plane. So you're gonna have one point on the plane. So you have one normal vector and one point on the plane. And this will allow you to construct an equation of the plane by just, you see, if you have any point x0, y0, z0, sorry, I make a mistake here. So the point is here. Okay, so you have one point on the plane and you have the normal vector. So if you have the point is called x0, y0, z0, okay, and you have the normal vector. So you like to find the relation between x, y, and z on the plane. So you have x, y, and z on the plane. Okay, so it's going to be, we need relation on x, y, and z. Okay, so we will need a relation on x, y, and z that is going to be the equation of the plane. So you see that if you construct the vector r minus r0 that I'm going to highlight the purple one. Okay, so this is the vector r minus r0. You see that this vector turned out to be orthogonal to the normal vector. So the purple one that r minus r0 will dot the vector n equal to 0. Okay, so you see the purple vector, which is r minus r0, is the vector that orthogonal to the normal vector. The orthogonal transfer into the relation n dot r minus r0 equal to 0. Okay, so you have this relation. So when you have this one, so you're gonna use n equal to a, b, c. Okay, so this is your normal vector n. Let me give some color. So you have n equal to a, b, c. And you have r minus r0, which is the purple one. So this one will be x minus x0, y minus y0, and z minus z0. So this one will give you n dot r minus r0. Okay, so the pink one dot the purple one, and you would get the equation. Okay, so when you dot this guy, you see that it's going to be a multiplied with x minus x0, b multiplied with y minus y0, and c multiplied with z minus z0. So this one will give you the scalar equation of the plane. Okay, so this is what we looking for. So this one will be the scalar equation of the plane. So normally the thing that I would recognize turned out to be this equation. This one is the vector equation. Okay, without dotting. So it's gonna be, you're gonna just leave two vectors like this, and then you're gonna find the dot product between them. Okay, so let me conclude how to find the equation of the plane. So you're gonna need two things. You're gonna need normal vector, and you're gonna need one point in the plane, and you're gonna set into this equation. And you see that your variable are x, y, and z. And the thing that we will need turned out to be the relation between x, y, and z. Okay, so let's try to find and sketch the plane to the point 3, 4, -1 with the normal vector n equal to 2, 3, 6. So you know that you have the normal vector n. Okay, so this one is the pink one. Okay, so that the pink vector, and you have the point x0, y0, z0. So in this case, you're gonna have n dot x minus x0, y minus y0, and z minus z0 equal to 0. So that will be the relationship between n and x0, y0, z0. So it's going to be 2, 3, 6 dot x minus 3, y minus 4, and z plus 1 equal to 0. Okay, and so you get 2x minus 3 plus 3y minus 4 plus 6z plus 1 equal to 0. Okay, so this would just 2x minus 6 plus 3y minus 12 plus 6z plus 6 equal to 0. And you can combine the term into 2x plus 3y plus 6z equal to 12. Okay, so this one will allow you to have the equation of the plane. Okay, so it's going to be 2x plus 6y, 2x plus 3y plus 6z equal to 12. So you see, it's not that hard. However, it's the number turned out to be many numbers here. So you get 6 numbers from 3 terms, 3 products. So let me resize this guy a little bit. The next question asks us to sketch. So we like to sketch the plane. Okay, so we have this equation of the plane, and we would like to sketch the plane. So we're gonna sketch by using the axes x, y, and z. So you're gonna have something like this, and you're gonna have the x-axis, y-axis, and z-axis. Okay, and you're gonna find the x intersection, y intersection, and z intersection. So we're gonna find x, y, and z intersect. Okay, so we're gonna find x, y, and z intercept. In order to find x-intercept, okay, so in order to find x-intercept, we shall let y and z equal to 0. So you're gonna put y equal to z equal to 0. So when you put y and z equal to 0, you would get 2x equal to 12. So you're gonna have x equal to 6. Okay, so you have x equal to 6. That allows you to have x-intercept. The next one, you're gonna put x and z equal to 0. So you would get 3y equal to 12. So you get y equal to 4. And finally, you're gonna put x and y equal to 0. So you're gonna get 6z equal to 12. So you get z equal to 2. Okay, so you have three intercepts, which are x-intercept, y-intercept, and z-intercept. So you're gonna plot them out. So you have x equal to 6, okay, y equal to 4, okay, let's put somewhere here, and you have z equal to 2. Okay, so you see that you can have, they have three intersect on the x-axis, on the y-axis, and on the z-axis. So you're gonna connect these three vertices together. So I'm gonna use other color. So you see that I'm gonna connect between these two guys together, connect between these two guys together, and connect between these two guys together. Okay, so this one will turn out to be the plane that we're looking for. So it's not triangle. It's gonna be this one. You have to think that it's gonna be this kind of plane. However, this one, you put this paper on the corner of the room. So you put this one at the corner of the room. You see that you have x equal to 3y, x equal to 6, y equal to 4, and z equal to 2. So you're gonna have some pieces of paper on the back that you won't see. Okay, so it's gonna be continue in all direction. Okay, so it's going to be continue in all directions. So that one will give you the whole plane. So the whole plane will look like this piece of paper that you see here. So it's going to be the whole plane. And if you put that onto the corner, like you see that the corner here is at the origin. Okay, so you see that it's gonna look like triangle. However, the shape of the plane is not gonna be triangle. It's gonna turn out to be surface like this one, and it can be continue in infinitely many directions. So it can be continue to through the back like this one. It's gonna continue here, and it can be continue in this direction as well. Okay, so that's how we determine the equation of the plane. Okay, so let me emphasize on you a little bit that after you have the vector equation, so you see that when you multiply A to this parenthesis, B to this parenthesis, and C to this parenthesis, you would get A in front of X, B in front of Y, and C in front of Z. So that will give you the coefficient of the normal vector. So you see that this one is the pink vector according to the first component, the second component, and the third component, and they consist of three triples. So it's going to be n equal to a, b, c, and it's going to turn out to be equal to constant. Okay, so it's going to be equal to constant. And this one is called linear equation of the plane. Okay, so this one is going to be linear equation of the plane. So when you see the linear equation, For example, like in this case, so if you see the equation of the plane given by 2y plus z equal to 3, the thing that you're going to see is going to be, hey, I have n equal to 0 to 1. Okay, so I have n equal to 0 to 1 because you not see x. So it means the number in front of x turned out to be 0. Okay, so that is going to be n. And we like to find and sketch the plane parallel to the plane 2y plus z equal to 3. So the thing that you will need in this case will be when you have two planes that parallel to each other. What does it mean? It means that you're gonna have one plane. Okay, so this one is gonna be my one plane, and you have another plane. So in order to have two planes that gonna be parallel to each other, the thing that you see is gonna be you have the normal vector are parallel. Okay, so it's gonna be the normal vector are parallel. Okay, so two planes are parallel if their normal vector are parallel. So in this case, you're gonna have this normal vector n to be the normal vector of the new plane. However, the point that you have here gonna be different. So the point is the point that you are having here. So you have the point is 2, 1, 4, and you have the normal vector turn out to be 0 to 1. Okay, so we're gonna compute the equation of the plane. So it's gonna be what? It's gonna be 0 to 1 dot x minus 2. Okay, so x minus 2y minus 1 and z minus 4 equal to 0. Okay, and so you're gonna get the equation 2y minus 1 plus z minus 4 equal to 0. So this would allow you to have 2y minus 2 plus z minus 4 equal to 0. So you would get 2y plus z equal to 6. Okay, so you have 2y plus z equal to 6 for the equation of this plane. And we're gonna try to sketch the plane. Okay, so we're gonna try to sketch the plane. So if you want to sketch the plane, you're gonna just find x-intercept, y-intercept, and z-intercept. So you're gonna put x equal to, not put x equal to, put y, z equal to 0, y equal to 0, z equal to 0. Okay, so you get 0 equal to 6. So in this case, it means that you have 0 equal to 6, which is false, right? So it means that you have no x-intercept. Okay, so we have no x-intercept. The next one, you're gonna put x z equal to 0. Okay, so you put x and z equal to 0 and you solve for y, so you get 2y equal to 6. Okay, so you would get y equal to 3. And the next one, you put y and z, not y and z, x and y equal to 0. So you're gonna have z equal to 6. Okay, so that is gonna be for the y-intercept and z-intercept. So you're gonna have this guy, okay? So you have z equal to 6, which is up here, and you're gonna have y equal to 3, which is down here, and you have no x-intercept. Okay, so you have no x-intercept. So we're gonna need another point in order to give us some guideline. Okay, so you see that it's not gonna be a closed triangle like we had before. So we can just have one side like this one. Okay, so it's gonna be, so it's gonna be just one side like this one. Yeah. Let me fix my pencil a little bit. Okay, so that would be joining these two guys. Okay, so I like to have that guy joining these two guys. It's not working that way. Okay, nice. So you will need to know how would this plane gonna be? How would this plane gonna be? So you may need like x equal, so you gonna have, it's gonna be the plane that is gonna it's not gonna pass the not gonna pass, it's not gonna mean that it's gonna pass the origin. So it's gonna be the plane that is gonna be along this line. Okay, so it's gonna mean that you need like the shape of the curve a little bit that you will have here. Okay, so you see that, so you have x equal to 0, and you're gonna get this one is gonna be the line that you can use as guideline. And when you like to sketch the plane, the thing that you're gonna do will be you're gonna try to draw. So because x can be any number, you're gonna draw the line parallel to the x-axis. Okay, so the way that you're gonna use is gonna be you're gonna draw a line parallel with the x-axis. Okay, I need a ruler. Okay, so I need a line parallel with the x-axis. So I'm gonna try to draw. So that working. So here you see that it's gonna be, you have the guideline, which is the line here that's gonna give you a guideline, and these two lines will be parallel with the x-axis because the x can be anything, so you can vary x. Okay, so this one is going to be just the thing that parallel with the x-axis because it's not going to come to the x-axis at all, right? So this one, how would I know that it's going to be parallel to the x-axis? Because we don't want the line that is going to intersect the x-axis at all. Okay, so if you have the line parallel with the x-axis, it can guarantee you that it's not going to intersect the x-axis, and that what will be the thing that we looking for. So you have x, you have y, and you have z, and the plane turn out to be this plane. Okay, so it's gonna be this one. The next example is gonna be about you gonna be given 3 points. Okay, so you like to find an equation of the plane that contain the point P213, Q4 to -1, and R6 to 2. So you gonna have the plane. Okay, so I'm gonna sketch the plane a little bit. So you're gonna get this one, this one, this one, and this one. Okay, so you have this plane and you have the point P, Q, R. So it's gonna be P, Q, and R. and you know that your point is P 2, 1, 3, Q is 4, 2, negative 1, and you have your R is 6 to 2, okay? So you like to find the plane that containing these 3 points. It's turned out to be unique because if you have 3 points in 3-dimensional, it's gonna be only one plane that gonna pass through this point all the time. Okay, so it's gonna be you have PQR that not on the same line. Okay, so that not pointing to the same direction. It's gonna be only one plane that you be able to find. So in this case, you're gonna have to find the normal vector. So you need the vector that perpendicular to this plane. So you need the vector that gonna perpendicular to this plane, and it's turned out to be the vector that can obtain from using P, Q, and R here. So you see that you have the vector. You can construct the vector PR and you can construct the vector PQ. Okay, so you can construct this vector PR and you can construct the vector PQ. So you have PR and PQ, okay? And you're gonna find the cross product. So you're gonna find the cross product between these two guys. So N here turned out to be parallel with the PR and PQ. Okay, so it's gonna be PQ cross PR. Why did I cross between PQ and PR? Because we need the vector that will perpendicular to PR and will perpendicular to PQ. So in order to have the vector that perpendicular to both PQ and PR, it's turned out to be the vector PQ cross PR. So we will find PQ cross PR. So you have N turned out to be just PQ cross PR. Okay, so you have N equal to PQ cross PR, and it's turned out that it's gonna be IJK and PQ. Okay, so you need PQ and PR. Let's compute them first. So you have PQ given by, so it's gonna be 4 minus 2, 2 minus 1, negative 1 minus 3. So it's gonna be 2, 1, negative 4, okay? And you have PR given by 6 minus 2, 2 minus 1, and 2 minus 3. So you get 4, you get 1, you get minus 1. Okay, so it's going to be 4, 1, and minus 1. So it's going to be 2, 1, and negative 4. And you have 4, 1, and negative 1. So you get PQ cross PR. And you're gonna have, okay, so you're gonna have the cross product. I would warn you that when you have PQ cross PR, it's gonna turn out to be the vector that perpendicular to PQ and PR, okay? So we need the normal vector. And one thing that you also need in order to find the equation of the plane will be 1 point, okay? So you can pick 1 point. So you can pick P, pick Q, or pick R. It doesn't matter. Okay, so it's going to be 1 point in the plane. Okay, so you need 1 point in this plane and you need normal vector. And normal vector will be perpendicular to both PQ and PR. Okay, so N will be PQ cross PR. Okay. So in this case, we're gonna compute the cross product between this guy. So like I did before, so it's gonna be ijk that we used to have. So you're gonna get 1 negative 4 1 negative 1 I minus j is 2 4 negative 4 negative 1 j, and you have k, which is 2 1 4 1 k, okay, and you will get negative 1 plus 4, so it's going to be 3i, okay. Let me write. So it's going to be negative 1 plus 4 I, and you have negative 2 minus 16. So it's going to be plus 16j, and it's going to be 2 minus 4k. So it's going to be 3i, and you have negative, so it's going to be negative 14j, and you're going to have minus 2k, okay? So you see that you need to check whether you get the correct cross product. So it's going to be 3 times 2, which is 6, negative 14 times 1, which is negative 14. So it's going to be 6 minus 14 plus 8 equal to 0. Okay, so it's correct. However, the next one is going to be 12, okay, minus 14 plus 2, so it's going to be 0, okay, it's also correct. So this one will be normal vector, okay, so this one will be normal vector, and the point that you have here is going to be 4, 2, and negative 1. So in this case, you're gonna have the equation of the plane, okay, so the plane is, so it's gonna be 3 negative 14 negative 2 dot with x minus 4 y minus 2 and z plus 1 equal to 0. So you get 3x minus 4 minus 14y minus 2 minus 2z plus 1 equal to 0. So this one will be 3x minus 12 minus 14y plus 28 minus 2z minus 2 equal to 0. Okay. So you get 3x minus 14y. Okay, so it's going to be 4x minus 14y and minus 2z equal to, okay, so it's going to be negative 14. Okay, so that will be the equation of the plane that you're looking for. Okay, so that will be the equation of the plane. Okay, so let me conclude the step that we have here. When we have 3 points, okay, when we have 3 points, we'll be able to find an equation of the plane passing through these 3 points by first finding vector PQ and PR. So this one will be your first step. And the second step, you find the normal vector N. Okay, so you have the normal vector N. And the third step, you need 1 point. Okay, so you need 1 point. So this one will be the third step. And the fourth step turned out to be you set up the equation. So it's gonna be just give you the final answer in terms of the equation of the plane. Okay, so one point that can be P, can be Q, or can be R. At the end, you will get the same equation. And the thing that you can see will be the normal vector turn out to be the coefficient on x, on y, and on z respectively. The next one gonna be, we like to find the point at which the line with parametric equation intersect the plane. So what is going to be for this one? So you see that if you have the plane look like this, okay, so if you have the plane look like this, and you can have a line that intersect with this plane, so it's going to be this line, and you see that we're going to have something in the back as well. Okay, so this one will be the intersection point. Okay, so it's going to be the intersection point, and this one is going to be line, and this guy is going to be the plane. Okay, so you have the line intersect the plane. So the way in order to solve for the point turn out to be, it's going to be, you see that you have x equal to, let's use the green color. So you have x equal to 2 plus 3t, y equal to negative 4t, and z equal to 5 plus t. And you're going to have the plane 4x plus 5y minus 2z equal to 18. So you see that in order to find a common point, you see you're going to just plug x, y, and z into the equation of the plane and solve for t. Okay, so you're gonna put into okay, and we solve for t. Okay, so you just put x, y, and z that you have into the plane and solve for t. Okay, so you're gonna get, so you get 4 times 2 plus 3t plus 5 minus 4t minus 2, 5 plus t equal to 18. So you get 8 plus 12t minus 20t minus 10 minus 2t equal to 18. Okay, and you're gonna solve for t, so it's gonna be negative 10, right? So it's gonna be, you combine the terms, so it's gonna be negative 10t equal to, you get 8, and you get, I would have, what is gonna be negative 10 minus 2. So I get 28 minus 8. Okay, so it's going to be 20. Okay, so it's going to be 20. So you would have t equal to negative 2. Okay, so you solve for t and you get t equal to negative 2. So put t back. Okay, so we're gonna have the second step. So that the first step. The second step will be you gonna put t equal to 2 back into x, y, and z. T equal to negative 2 back into x, y, and z. okay? So you would get x equal to 2 plus 3 times negative 2, y equal to negative 4 times negative 2, and z equal to 5 plus negative 2. So it's gonna be 8. Okay, so it's gonna be 8 for y, it's gonna be negative 4 for x, and it's gonna be 3 for z. Okay, so the intersection point is, okay, so the intersection point is negative 4, 8, 3. Okay, so the intersection point turned out to be at negative 4, 8, 3. Okay, so that's gonna be the intersection point that you're looking for. So this is what it looked like. It looked like that you have the plane and you have the line and you like to find the intersection point. So normally it's gonna be only one point. Okay, so it's gonna be like you have the plane and the line and you're gonna meet in the middle like this one, and you see that it's gonna turn out to be only one intersection point, and this is the intersection point that you are looking for. Okay, finally, we like to have the two planes intersect each other. So you have two planes, okay? So this is my first plane, this is my second plane, and you're gonna have the intersect. So you see the intersection here. The intersection will give you a line, okay? So the intersection turn out to give you a line L that you can see from this picture, okay? So this one will be the line of intersection. Okay, so it's gonna call the line of intersection. But first of all, we're gonna find the angle. Okay, so you see that when you have two planes intersect, in this case, you're gonna be able to find the angle between two planes. What is the angle between two planes? It's gonna be the angle that you have something like this. So it's gonna be the angle that you have here. So how would we determine the angle between two planes? It's gonna be, you're gonna find the angle between two planes by just using the normal vector. So the angle between two planes, the interpretation turned out to be just the angle between normal vector. Okay, so it's gonna turn out to be the angle between normal vectors of these two planes. So you need normal vector. So it's gonna be n1 from the first plane, and you're gonna read this guy from the coefficient in front of y of x, y, and z. So in this case, it's gonna be 1, 1, 1. Okay, and you have n2, which is the normal angle, the normal vector, 1, negative 2, 3. Okay, so it's going to be 1, negative 2, 3, and 1, 1, 1. Okay, so they are normal vector. And you like to find the angle between n1 and n2. Okay, so it's gonna be, you have n1, n2, and you like to find the angle between them. So in this case, you need data. Okay, so you need data. So it's gonna be cos data equal to n1 dot n2 over norm n1 norm n2. Okay, so that will be the formula that we used to have. And you have n1 dot n2 to be 1 minus 2 plus 3. Okay, and norm n1 will be root 3, norm n2 will be root 14. Okay, so it's going to be 1 plus 4 plus 9, so it's going to be root 14. So in this case, it's going to be 2 over root 3 root 14. Okay, so it's going to be 2 over root 42. Okay, so this one you have cos theta equal to 2 over square root 14. So the way to answer this guy will be theta turn out to be arc cosine of 2 over root 42. Okay, so that will be your final answer. Okay, so you have cos theta equal to 2 over root 42. So you have theta equal to arc cos of 2 over root 42. The next one, we like to find the line of intersection. So you see, in order to find the line of intersection, you will need, okay, so you will need the direction vector of the line. Okay, so you need the direction vector of the line. So you're gonna need one, okay, the direction vector of the line. Okay, and the second one will be you need 1 point on the line. Okay, so you have 1 point on the line and the direction vector of the line L. So in order to find the direction vector, it's gonna be, you need to notice that if you have the vector n1, okay, so let me draw the vector n1 and n2. So you have the plane x plus y plus z equal to 1, and you're gonna have the vector n1 turn out to be the vector that perpendicular to this line. So it's gonna become something like this. Okay, so it's gonna become something like this. Okay, so it's going to be the vector that perpendicular to that plane. And the second one will be the vector that perpendicular to this plane. Okay, so it's going to be this one. So it's going to be okay, so it's gonna be like this. Okay, so it's gonna be like this. So you see that it's gonna be the vector n1 and n2. Okay, so you have n1 and you have n2 with the green vector. So you see that you need the vector that is going to become our direction vector. And our direction vector is the blue vector here. Okay, so it's going to be the blue vector here. So this blue vector turned out to be the vector that lies on the plane, the first plane and the second plane. Okay, so it's going to be the vector, the blue vector turned out to be the vector on both planes. So in this case, the thing that you see will be the blue vector will be perpendicular to the plane. Okay, so it's going to be the blue vector turned out to be perpendicular to the plane n1, and also the blue vector turn out to be perpendicular to the plane n2. Okay, so if you see that in my n2 is somewhere here, okay, so it must be perpendicular to this vector, and my n1 is something like this, so it's perpendicular to the vector, the blue vector. Okay, let me draw it again. So that my n1, okay, and this my n2. Okay, so this my n2. So you see that it's going to be the vector that perpendicular to, so my blue vector perpendicular to both n1 and n2. So it's gonna be the direction vector, okay? So this one we can see that, okay? So we can see that okay, so we can see that this vector perpendicular to both n1 and n2. Okay, so it's gonna become, so it's gonna become, so it's become the vector that perpendicular to both n1 and n2. Okay, so this blue vector turn out to be the vector that both perpendicular to n1 and n2. So we may use n1 cross n2. Okay, so we may use n1 cross n2. So this will be just the key idea. Okay, so this will be just the key idea for finding this guy. Let's use the highlight that make this guy a little bit darker. Let me write this one. It should be dark enough, right? So N1 and N2. Okay, so it's going to be this one. We may use N1 clause N2. Okay, so after we know that, we're gonna use N1 cross N2. So we're gonna have, okay, so we're gonna have to find N1 cross N2. So you set this thing up. So it's gonna be IJK, and your N1 turned out to be 111, and N2 turned out to be 1, negative 2, and 3. Okay, so you have n1 cross n2 given by 111 and 1, negative 2, and 3. So you will need this one. So you're gonna compute n1 cross n2. Okay, so it's gonna be I, so it's gonna be 1, 1, negative 2, 3, I minus, for J, it's gonna be 1, 1, 1, 3, J, and K will be 1, 1, 1, negative 2, K. Okay, and it's gonna turn out to be 3 plus 2i minus 3 minus 1j plus negative 2 minus 1k. So this one becomes 5i minus 2j and minus 3k. Okay, so it's going to be this vector 5, negative 2, 3. Okay, please check. So you have 5 and 1, 1, 1. So it's going to be 5 minus 2 minus 3 equal to 0. Okay, and you have 5 plus 4 minus 9 equal to 0 is also okay. So you have n1 cross n2 given by this guy, 5, negative 2, 3. Okay, so you get, okay, so you get the vector. So this one will give you the direction vector. Okay, so this one is going to give you the direction vector of L. So you get the direction vector of L. The next one we need is 1 point, okay, on both plane. Okay, so the next thing that we shall need will be next, we need 1 common point on both plane. Okay, so we need one common point on both plane. So you gonna solve. Okay, so we solve. So you have x plus y plus z equal to 1. And you have x minus 2y plus 3z equal to 1. Okay. So you have x plus y, x minus 2y plus 3z equal to 1. So we're gonna solve these two equations. We don't need all things that common. So we're gonna need just one common point. So we're gonna just put one number. Okay, in this case, I'm gonna choose to put z equal to 0. We put that equal to 0 because we need to get rid of one variable out. So you get x plus y equal to 1, x minus 2y equal to 1. Okay, so we just need to get rid of one variable, and it's going to be just two variables here that you can see that it's going to be using the technique that you used in high school before. So this one will be 1 minus 2. Okay, so you get 3y equal to 0. Okay, so you would get y equal to 0. And when you have y equal to 0, you plug into the first equation, you would get x equal to 1. Okay, so you have the point is, one point is, okay, it's going to be 1, 0, 0. And the thing that you may try will be if you plug in x equal to 1, y equal to 0, and z equal to 0, it satisfies the first plane. And when you have x equal to 1, y equal to 0, z equal to 0, it also satisfies the second plane. Okay, so you need only one common point. You may ask me, hey, can we find something else like if you solve for, if you have x equal to 0 instead, and you're gonna solve these two systems in order to find y and z, that can be done, yes. So it's gonna be 0, and you're gonna have y and z, and you're gonna get new point. Okay, so that can be done as well. However, we just need one point, so we don't need many points. So you can just pick one. So you get rid of y, get rid of z, and you'll be able to solve for the equation simultaneously. Okay, so we have one point and we have direction vector. So we'll be able to have the symmetric equation. Okay, so the symmetric equation is given by, okay, so the symmetric equation are given by, so you have x minus 1 equal to y equal to z, and it's going to be over the vector phi negative 2, negative 3. Okay, so that is gonna be the symmetric equation for the line of intersection. Okay, so this one, the symmetric equation is gonna be this one of the line of intersection. Okay. Okay, so we gonna conclude everything that we studied so far. So we have equation of the plane. In order to get the equation of the plane, you need normal vector, which is the vector that perpendicular to your plane and one point on the plane. And you set up the equation of the plane in this form or the vector form. Okay, so you have n dot x minus x0, y minus y0, z minus z0 equal to 0, and you obtain the equation of the plane. And if you have 3 points, you allow to find an equation of the plane by just you find vector PQ and vector PR, and then the equation of the plane turn out to be the normal vector given by PQ cross PR, because we need the vector that perpendicular to the plane, so it will perpendicular to both PQ and PR. And then if you have the line and the plane, you'll be able to find the intersection point by just plugging x equal to something in terms of t, y, and z in terms of t into the plane, and so for t. And then you're going to plug t back into the equation of the line in order to obtain the point x, y, and z. And final thing that we study will be, in order to have two planes, if you have two planes, you can find the line of intersection. When you have two planes, the intersection turn out to be line. And if you want to find the line of intersection, the direction vector turn out to be just n1 cross n2. And when you have n1 cross n2, you're gonna find the common point. The way to find the common point turn out to be you just get rid of one variable by letting it to be 0, and so for the system of equations simultaneously for x and y, something like this happen. Okay, and that will give you the equation of the line of intersection. I will leave you one example for working on your own. We like to find the symmetric equation for the line of intersection of the plane x plus y equal to 2 and x minus y plus z equal to 4. So you will need n1 cross n2, and you will need one common point. Okay, so you will need n1 cross n2, and you need one common point in order to find the line of intersection. Okay, so I will give you the solution at the recitation. Okay, so that's it for this clip.